I love my hobby, but there is one job that I really hate, and that is cutting steel with a hacksaw. Especially 50 or 60 millimeter solid bars and such. Absolutely hate it. So it's time to do something about it. But what is on the market is too coarse, too big, too limited for me. I make small instruments and tools, and will rarely have to saw through anything longer than, say, 25 centimeters. So, I want a small saw table with which I can tackle those thick bars, but with which I can also saw through smaller sheets of metal, and do so with precision, and the saw table must be able to be put away when I don't need it. A tabletop model that is as small as possible seems ideal to me. This is roughly what I have in mind. On the right, a sketch of the most common bandsaw model. But even without a table, this is already way too big for my purpose. On the left, a first idea of what I want to build. About the same options as the right model, but much smaller and with a table. However, there is a tricky point, and that is the diameter of 4 discs in my model. It is only 80 millimeters, which means that the saw band is bent much more strongly than with the 20 centimeter discs. Some rough calculations teach me that the strain due to bending is in the order of 0.6%. That would mean bending in the elastic region of steel. In theory, it could be possible, but a practical test is desirable. So let's start by making 2 80 millimeter discs for testing. I now use nylon because I don't have any harder material available. In the final model, it will probably be aluminum. Using a temporary tool bit made from some scrap, I give one of the 4 discs a slight curvature so that the saw band wants to find the center of the circumference of the wheel. With an extra flexible saw band that is only 0.5 millimeter thick, I test here whether the saw band can withstand the stronger curvature of the wheels without any damage. The usual speed will be around 300 to 400 RPM, but here I go up to 10-fold without any problems, so that looks fine. That's encouraging. Time to make some more detailed sketches of the parts, including the saw band guides, which I will make first. The saw blade is guided between adjustable ball bearings. The opening width and location can be adjusted a few millimeters. A slightly wider blade can also be used, and the saw blade can be accurately adjusted vertically by moving the bearings slightly. Now, it is time to work out the C-frame, the backbone of the bandsaw, in every detail. Now that I have the most important dimensions of the C-frame, I can start building it. Using some tapping blocks and the digital readout, I drill all the holes through all 4 parts at once. I get a lot of benefit from this little instrument, and I use it often and happily. See my video, A Tool with a Punch, about this precise tool. Here I make the bushings in which the wheel axles will be mounted. Here am I trepaning the hole for the motor gearbox. And the holes in the C-frame into which these bushings will be pressed later. Note to self, something less tight is also allowed. The two additional axes are designed eccentrically so that I can easily tighten the saw band. I purchased a 400-watt brushless DC motor, which requires 48 volts of power. A planetary right-angle gearbox reduces the maximum speed to 400 RPM. In practice, this will mean a continuously variable cutting velocity, with a maximum of approximately 100 meters per minute. Okay, let's do a temporary assembly to test the operation of the saw. My apologies for the poor lighting. That's encouraging. Everything seems to work as I intended. The saw does not run off the discs. The speed is easy to regulate. The noise level is modest. However, there is a small problem which I expected. The saw slips quite easily on the smooth nylon disc. Time to tackle that problem too. I glued a hard rubber disc to a clamping plate with crazy glue, and I trepanned a ring from it that was glued tightly around the nylon disc of the drive motor. That should solve the problem. But then, disaster strikes. After testing the bandsaw for a handful of minutes, I noticed that it was moving backwards, away from the discs. I soon found out the cause: dozens of micro cracks in the extra hard front of the bimetal saw band. It was only a matter of minutes before it would snap, and sure enough, it did. Apparently, the strongly varying strain with a diameter of 8 centimeters leads to so much metal fatigue that the saw does not have a long life. Of course, it's just a prototype, but it was still a disappointment. Some research on the internet taught me that there are apparently no bandsaws with discs smaller than 12 centimeters in diameter. So I think that's the way to go. This means that the table saw will become quite a bit larger, and that I will have to make the frame again, but one size larger. Right now, I'm mulling over these two models. I invite anyone with ideas about this to express themselves in the comments. To be continued. Thanks for watching, and see you next time.